Hello and welcome to this module in our Tetration video series. My name's Rob and I'm joined here by my colleague Tim, and together we're going to talk in this session about Tetration inventory. And this is a key part of really getting started with Tetration, as it builds out the foundation for what we're going to achieve in terms of security and policy around that. So Tim, we start with the world that our customers are operating, right? We've got hundreds, thousands of workloads. They're deployed across different environments in the data center, in the cloud, and basically beyond that, they've also got their users that are accessing those applications. So it's a pretty broad, diverse world that they're operating in. And really the foundation, or getting started with securing this environment, is having a better understanding of what they actually have today. So what would you suggest would be maybe some of the common elements across this environment that I guess we could use to start building out an inventory? What are some of the attributes or ways that we could start to break it down into something more meaningful?
Yeah, you know, it's interesting because you have all of these different cloud providers, you have the on-prem hypervisor, you have the containers over there, but they all do share something in common with each other, like what application are they part of? What business group owns that application? Where are they physically located? What type of data are they holding? Those kind of things, despite the fact that those applications are deployed across all of those different environments, they do seem to be tags and inventory annotations that we see quite frequently.
Yeah, so I guess what's interesting about that is you never once mentioned what VLAN they're on, what subnet they're on, what IP address, all of those traditional networking constructs, which has really been how security and segmentation has really been done in the past, right?
Yeah, I find them all really to be around the identity of the application, or the type of data it holds, or the kind of severity or the criticality of that particular workload.
Yeah. So this really allows us to start building out policy for the application in a much more flexible manner, right?
Yep.
The use of just more natural terms that have meaning to application owners, to business owners, about their applications, their worlds that they're trying to secure, so that we don't have that translation issue that's always been there and really slowed down security in the past, right? So let's take a look at how we start to build an inventory in Tetration to start to be able to apply those terms to what we have in this environment. Now, we actually have some building blocks in Tetration for how we actually create some sort of structure to that world. Now, there's different elements here that we'll expand on just to, I guess, create a greater sense of how they actually are created and developed in Tetration. But it really kind of starts with this concept of a hierarchy, and that's the ability to structure the inventory, and the inventory is basically the view of all IP addresses that are in the system, every IP address that's communicating to and from those workloads, and being able to put them into some sort of container. And the purpose of that is so that we as humans can make some sense of it, right? We don't remember all of the attributes and the IP addresses of our hundreds or thousands of workloads. So being able to put them in some sort of understandable structure with a name or a label is really a meaningful first step, right?
And so you mentioned all of those IP addresses. Is that just IP addresses I own, or could it be partners?
It could be anything.
Yeah.
So really what we're wanting to be able to define is policy that is defined to anything that's communicating in your environment.
Okay.
Now, whilst we're sort of focused on the security of those application workloads, what else do they touch? What else is accessing those? What are they calling out to? All of those need to be built into the policy. So we need to understand all of those moving parts. And that does extend to partners, to users, to all other components. Whether they have an agent on them or not, we still want to define what they are.
Okay, so I don't need to have an agent on every device that might be part of my inventory?
Absolutely not.
Okay.
No. So we're focusing on the workloads themselves, but we can achieve extensive identity, I guess, sort of other attributes to any IP address in the inventory based on other systems out there, other systems of record. So on the users, in the campus space, we might want to understand what user is logged onto a particular machine, what group are they a part of, etc. We can get that information without having an agent on that particular device.
Seems useful.
Okay. So maybe this is a chance to actually take some of these concepts and just to expand on that. I think if you don't mind grabbing a whiteboard pen, what I'd like to just really expand on is this concept of having an entire environment and breaking that down into scopes. So a scope allows us to build a hierarchy. There's a structural element. So at the high level, we can break it down fairly coarsely, and as we get further down, become a little bit more granular and detailed with what we're building there.
Okay, so let's draw this root scope at the top here. We'll put a nice little circle, and that's the root. What's the root scope going to be named if I'm using Tetration as a service?
So that'll be effectively aligned to the company name, the domain name. So this is your world as a tenant in Tetration SaaS.
Okay, so let's say that I'm Acme. My root scope is going to be called Acme.
Okay, and the root scope is really the holder for everything. And so what we want to do now is to start to break that down. What's the first level of breakdown that probably is somewhat meaningful to an organisation?
Well, as an organisation, probably I'd like to identify what's inside and what's outside my organisation. So I can put that as the next layer down.
So let's pull down everything that we control or is under our responsibility as an organisation. So effectively, we could call that our inside.
Okay.
And that distinguishes us from the outside. And then as we start to use these scopes, we can then start to break that down even further. So the next level could be, for instance, what are the various types of inventory items that we have, or the different parts of our environment that need to talk to each other?
Well, you mentioned it earlier that I could refer to all types of different entities inside my organisation. So I'm going to say maybe my data centre, my campus, and my partners. Does that sound like something that we could do? Sure.
As long as they're all inside the organisational control, then that's fair.
Okay.
Partners themselves, if they're outside of your control, could be something that you could break out above.
Let's say that this one is DC, and we'll follow this DC one down.
Yep.
What typically might we see underneath the data centre?
So what we're doing here is starting to now build a model for where our applications reside. So we've got applications in data center, in cloud. They have different application owners. Now, one of the things that we're doing here is not only just breaking it down from a policy view, because each one of these objects has the ability to be a policy control point, but it's also a way to define role-based access. So we can actually start to provide control of policy to application owners as we deem fit, so that we're starting to take pressure off that divide between applications and security, giving them some room to actually develop their own policies, all within the confines of what's allowed in the system.
Okay, so underneath the data center, perhaps we could split it down to applications and services.
Yep.
That seem like reasonable?
Yep.
Let's say.
So you could have something that is a group of applications there under somebody's administrative control. Yep.
And we'll put services over here. So underneath there, I could define an application per business group.
So here's where it's flexible. Nothing here is set in stone. Different organisations will see their environments differently. But typically there is an application and there's the environment that it's deployed in. So you could have an application that consists of multiple environments, and you might want to apply different security controls, have different owners for the role-based access control across each of those. So within your app space, you've got your applications, and then those have the different environments associated to them.
Okay. So if we put in our example here app 1, app 2,
Yep.
And then perhaps you could tell me a little bit more about how we would get this scope tree to be filled out via the inventory.
Yes, we'll step straight into that in a moment.
Okay, app 1 and app 2. So we have a nice tree structure here that can
Yep.
take me all the way down from the entire universe down to the inside of my data center through to data center, apps, and then app 1 and app 2.
That's right. So we don't need to completely populate this for everything day one. So this is just really to introduce the concept of the scopes and then the ability to actually apply filters across those as well, because the filters gives us another lens across the inventory. So it's a way to, say, perhaps be able to selectively group workloads with a completely different set of attributes. You might want to choose all production Windows servers. You might want to choose all servers that have a specific level of criticality or that are defined as part of a specific zone. That way you can apply policy in different ways across this tree as well.
So you're saying that perhaps I could write a filter that would select endpoints across multiple scopes?
Absolutely. Yep.
Interesting.
So that the filter could be written to be specifically tied to a scope if you wanted to restrict it in that way, or you could actually apply it across the entire tree if you want as well.
Okay.
Just based on flexible attributes. So I think at this point, that's just to introduce these concepts. Now we'll get into how we actually apply the attributes to the inventory to actually give that definition to the individual workloads. So we know the workloads in the environment, or any endpoint, it has an IP address. It's communicating on the network. Could be IPv4, could be IPv6, but we've got different layers of context that, as a business, we either know already or that we want to be able to use for things like policy definition and control as well. So some of those will be delivered by the application owner. Application owners tend to know their workloads pretty well. Mm-hmm. We've then got other demands. We've got the security teams. They've got their own set of rules and policies that they want to make sure always apply to the workloads. We've got regulatory requirements that are defining those sort of regulatory needs, and we want to provide visibility and control from that perspective as well. And then you've got not only workloads, but users and devices. And now they tend to have very different set of attributes, right, and different sources of getting that information. So let's just take a look at what that might look like, right? We have an IP address in our environment. What do we know about it? Now, you just sort of built out that idea of just breaking down the environment. Now, one of the ways that we can do that is not by tying that specifically to IP addresses, but tying it to something we call annotations. It's an attribute that's associated to an IP or a subnet.
So you use the word annotation. Are there any other words that I might be familiar with for the term annotation?
Yeah. Tags, labels, attributes. It's basically a way of just applying some sort of context to a given entity.
Okay.
So in tetration, we use the term annotations. That's what we'll be really sort of focusing on, but it's fairly generic in terms of the other terms that apply there as well.
Okay.
So we know that we've got our internal address space. So we, some of you will have a record of that. We can pretty easily define that that's part of our responsibility. So we can actually tag anything within that subnet or those subnets with a tag that's our organisation name. We can then go the next layer down. Well, what of our entities exist in data centres or clouds or in campus or wherever they might be? So in this case, this particular IP is part of a subnet range that exists in a cloud. So at this point, we've already basically built the means to dynamically apply a workload to a scope by simply matching on a set of these attributes.
Okay.
So that's really what we're sort of trying to reach, is the point where the inventory and the system is dynamic and it's continually adjusting to changes in the environment, changes in the attributes that apply to the IPs.
So you mentioned dynamic. Exactly how can I get these annotations into the system?
Great question. In a lot of cases, The starting point is simple. We have tables. There's this sort of stuff that at the subnet layer is driven by the different teams. They might have different records that associate those together. As you get closer into the workloads themselves, and we'll see some examples in a moment, that's where we want to be able to start integrating with external systems of record. You don't want to be continually having to upload CSV files into the platform, right? That's
it doesn't sound fun to me.
Less than dynamic, right?
Yep.
It is a great way to get started. It's an easy starting point, but dynamic policy comes with dynamic change, dynamic inventory as part of that. So as we start to expand on the information we have per workload, this is again where we start to populate things that relate to the application that workload in this case is serving. We know also what environment that is part of. So is this a production workload? Is it a dev? We might have, and most certainly will have, different policies associated to those based on those attributes. Those sort of top layer of attributes, they're let's say the more application-specific entries. And they're also the things that, as we'll see in subsequent modules, lead into the scope definition and so on. But we also have other very important attributes that we can assign to the workloads as well. So regulatory requirements. It's simply the ability to define a set of user-defined attributes per inventory entry that can tailor it to whatever it is that you need as an organisation. So regulatory requirements could be like PCI, whether it's cardholder environment or out of scope. You'll be able to get visibility of those attributes for regulatory compliance, but also use that for policy definition as well, regardless of how and where those workloads are deployed.
It seems really useful. And if I'm looking at it right now, I think we have 8 in total annotations here that we've applied to the endpoint. 8 seems like a good number. I definitely wouldn't want to get rid of any of those. I wouldn't want less than 8 for sure. How many can we actually apply to each endpoint in the inventory?
That's a great question, Tim. Now, I should highlight that these field names are fully customizable. There is no rigid set of attributes that must be defined in Tetration. Right? You define what makes sense to you, and then we use those for dynamic query. The system allows for up to 32 of these user-defined attributes. And on top of that, we can then have additional attributes that come in from our external systems as well.
Okay, 32 per endpoint. I would like to see how I could use that many annotations per endpoint, but I'm sure there are customers where it's like that, right?
Well, I think it's about having the right data in the system for the right outcome. It's pointless putting junk information in there. It just fills the inventory and the database needlessly. But as long as it's relevant and it has a purpose, then it's very welcome to come in here. But it gives you that flexibility that you need to really deliver a comprehensive policy at scale.
So what you're saying is the flexibility is there, but think about every annotation, make sure it has a purpose, make sure you have a real reason for that annotation being in the system.
Absolutely. So I think we've kind of touched on a couple of these components, but this is really just a little bit of guidelines, a bit of thinking about how we actually build the annotations. So the initial sources of data, and this is really when you're getting started. It's a question of what do you have already. Now, that information typically exists already. So network level information in an IPAM, could even be in a spreadsheet somewhere. It depends on the customer and how they actually track that information. It could be something available in the routing tables. But network level attributes are also inherited by the subnets or the actual workloads that exist in them. So if they're tagged at the higher order network, that will trickle down to the underlying workloads. To add more detail, and this is where we start to get more into the application-specific attributes, that's where we start to look for more of the host-based or workload-based systems of record, and typically they're things like CMDBs. They could be coming from tags that maybe the application or the systems guys have added to the workloads when they're being deployed. That's across hypervisor environments, cloud environments, but typically, again, the application specifics, it tends to be more of the application owners have a good degree of detail about those.
Okay, and I can have multiple sources of data coming into the system at the same time?
That is correct. Yeah.
Okay.
So and again, so we've got inheritance in that, and the ability to override that as needed. Tetration actually merges the data sources that are coming in. So if we've got a particular field, and there's different inputs to that, it will actually bring that together to give you a consistent view for that workload.
Okay, so I can use Tetration to almost unify many of my different disparate sources of truth into one single inventory database.
Exactly, yep. And it will keep track of those. So
Okay.
that inventory, the annotations that we associate to those are recorded along with the flow records from the point that they're annotated onwards. As is any policy-based decisions that get made based on the queries against those attributes.
So we keep a historical view of these annotations, and I can see them in the past and how they've changed.
Exactly, yep. So key to this, obviously, is the accuracy of the data. Now, often we talk to customers and talk about CMDBs. What's the general level of confidence in the quality of data there, Tim, from your experience?
The general level of confidence in CMDBs, I'm going to say it's usually quite low.
It's generally on the low side, but there is a great appetite for improving it and getting it right. Now, what we find is customers are going through a refinement process. How do I improve the quality of data in there? And one of the things that we'll see and we'll explore is how we can take there will be sections of that data that there is a reasonable degree of confidence in. That's a great starting point. We can take that in. Part of the discovery that we will go through with tetration and the dependency mappings and so on is to find out where there are exceptions to what is expected. Now, those exceptions could actually be founded on the basis that your data, isn't 100% accurate.
Okay.
But it does highlight that, so there's a way to then go back and improve it.
Okay, so what you're saying is by using tetration and having a valid use case for a lot of that CMDB data, it actually helps you go back and improve the quality of the data that's in the CMDB as well.
Correct.
Okay.
Yep. So we talked about manual versus dynamic, and again, our goal is to become a dynamic system. Now, yes, getting started, and I'll show you an example in a moment, is as simple as taking a CSV from the IPAM, from the CMDB, and ingesting those into tetration, so we can upload those. That gets us moving. But we definitely want to move towards a much more dynamic model. That's something that we'll have specific modules to focus on how we integrate with external systems through our orchestrator capabilities and so on, so that it actually allows for that. So whether it's API driven or orchestrator driven, we bring in more data into the platform and make that dynamically refreshed, which means your policy is always going to be refreshed and reacting to the changes in those annotations. So we start simple and we grow. That's really the foundation. We don't want to start and boil the ocean and just get wound up in how our data isn't high quality. We don't need to have full annotation for every host and every workload.
Yep.
We start with what's really required to get us moving, and then we expand beyond that.
I like that. Keep it simple approach.
Keep it simple, because it will, as you start to build, some of the initial discoveries will find things that once you correct and you fix once, will be there and will be resolved for all subsequent operations. So it's a constant refinement process as we go through, so an iterative approach. So different sources of data. The user annotations that we spoke to, direct upload, or the ability to integrate through APIs.
Mm-hmm.
So different systems that we can actually integrate to build out those user annotations. The orchestrators is where tetration can actually reach out into external systems and, again, pull in a whole additional set of information. This is where we start to tie in with everything from the hypervisors, the cloud providers, even Kubernetes as an example, to bring in those dynamic attributes as the applications are actually being deployed and as they evolve through their life cycle.
So you're saying if I have workloads that are on one of these particular orchestrators, for example, you're going to automatically suck up information into the inventory about those workloads?
Correct.
Nice.
So as those workloads are deployed, if they're, for instance, they have either attributes or tags associated to them, Tetration will ingest those, so they will automatically be scoped correctly. The correct policy will be associated to them, and basically the security model will evolve as those applications come and go. And that's really to do with that much more dynamic environment we have with the newer applications, which change much more frequently than ever before. Okay, we have some additional annotations that we actually bring in. That's part of the internal feeds from Tetration that also give us additional understanding of those flows, particularly around security compliance and so on.
Okay.
So how do we do this? We talked about taking a CSV and uploading it as a starting point. Now, if we start with the networks, that's typically the easier part. We've just basically got a table. We can apply some subnets into that, and then we can apply some annotations. And that's basically IP as the key with some columns that associate some particular data according to these specific fields into the system.
Oh, so I don't have to annotate every single endpoint inside this /8. I can just put that one annotation across the entire subnet.
Correct. So remember we talked about inheritance. So inheritance means that if I apply this, so in this case, our Acme org has decided everything internal is RFC 1918 address space. And they've just said, well, anything that's 10.00/8, org equals Acme. And I will build a query around that. That becomes my foundation for what is inside my environment. Everything else that exists within those subnets also will inherit those tags unless they're overridden for some specific purpose. So what we can do now is add the next level of detail. So as we were kind of stepping sort of through that scope structure, the next level is, well, where do these workloads exist? Are they in the cloud? Are they in the campus or branch network? Whatever that might be. So cloud, data center, there's different ways that you can break this up depending on how specific you wish to be. But it's a matter of taking, again, subnets and then adding additional attributes to them. So in this case, a portion of the network 10 here is going to exist in cloud. So we'll take that IP space and we'll tag it with cloud, which basically means that that address will inherit org acme and type equals cloud.
So even if I put a more specific annotation in a separate row, it's going to make sure that Acme is still filled out here within inside the annotations database.
That's the inheritance taking place there. Yep. As we step into the host space, and again, this is the areas where perhaps the application teams have more specific detail and want to be able to help us to actually build this out. These fields, again, we've got some that we've talked about that help us in defining scopes, as an example. And then there's a whole lot more that we'll add to that, again, with an appropriate sort of set of an understanding of what they're to be used for, making sure that they have a purpose. Similarly, so we've got specific IP addresses now. So host IPs /32s, they will inherit the network attributes that we just saw on the previous page, but they've also got some additional attributes here. So what service they're a part of, the app, the environment are all done on a per host basis, typically. It's, again, dependent on the organisation, how their environments are built up. If they want to sort of tie into any existing constructs, that can be brought into the annotations here as well. And then we've got additional information. Completely user-defined. Maybe things like location are relevant, maybe not. Compliance around other attributes can be built into this model as well.
So the long and short of it is I can define whatever I want. I have the flexibility to use inheritance, and in the back end of the system it's going to make sure every single endpoint gets the full set of annotations applied to it.
That is absolutely correct, and it will continually refresh that. And as we get to the discussions around policy in subsequent modules, the policy will always adapt to the changes in the inventory.
Okay. Seems like a very powerful construct to use.
It is, and it's foundational for how we actually achieve this. So, lastly, it's really getting started is a simple case of what have we got already, and this can be just done day one. Day one, we've got what we believe we want to annotate with. We've got some attributes to define at the network level, some attributes to define at the host level, and again, don't need to do all 20,000 workloads in your environment day one. Start with where the confidence is and what we've got to start with. And then we simply upload that through the user interface. Okay? So we select a file, we click upload, choose that this is going to be an additional step that we want to add this as opposed to delete or update. So we want to make sure that we're including this information, and then that provides us with a set of attributes in the system that are now being tracked.
Looks good. And so for every workload, I'm going to be tagging, in this example, the application, the environment, the organization, the service, and the type. And if I need to, I can delete them, or I can even clear the entire database if I make a mistake.
Yes, so there is clearly role-based access control around each of the components in Tetration, and that gives us the ability to have additional information brought in, as well as control around how it can be updated and deleted. But yes, you've got flexibility to change the annotations that are in the system, to adapt to changes in the environment, and to always add new ones as they become relevant to you. Yep.
Sounds useful.
Okay, excellent. So that concludes our module on inventory. For more detail, please go to cisco.com/go/tetration. Thank you.